Camping is such an adventure. I love how there's a surprise around every corner. Except when I'm surprised with a sudden allergy attack. Luckily, I've got Claritin D to attack back. And I didn't even need a prescription for this.
Get fast, powerful relief from your worst symptoms, like nasal congestion. It's so fast, it starts working in as little as 30 minutes.
Now, I can enjoy sleeping under the stars instead of sneezing under them.
Claritin Clears. Use as directed.
Test. Hello. Hi guys. Hello chat. I should say hi to the chat through the chat. Hang on a second. Chat. Hello. There we go. Where's my live stream chat? Where's my chat? There we go. Got my YouTube chat. Check my Kick chat. Where's my Kick chat? Hello, Kick chat. There we go. I think we're all set. All my chats are live. And we're doing a development stream. I'm more of a C and C++ programmer, but I just want to kind of do a head first dive into Python, and then if you got any suggestions on what we could program today, I'm all ears. So let's just get started. Alrighty then. Let's go to my monitor. So I already went ahead and installed what's called VS Code. This is the environment, and also installed Python 3, the latest regular version. Also installed an extension. What was it called? Yeah, it was just called Python. So Python language support. So now we could do some basic things. So since I'm not really much of a Python developer, I think we would start by doing some exercises here. Just try to get used to working in this environment and learning the language in general. As some of you may know, this is not my first weapon of choice, this language. I usually do C and C++. So let me pull up some tutorials. Let's see. Python 3 tutorials. The Python tutorial? Check it out. Is there any way we could make that bigger? If you do much work on computers, eventually you will find that there is some task you'd like to automate. For example, you may wish to perform a search and replace over a large number of text files, or rename and rearrange a bunch of photo files in a complicated way. Perhaps you'd like to write a small custom base or specialized GUI application or a simple game. If you're a professional software developer, you may have developed Java libraries. Performers usually write, compile, test, recompile, cycle is too slow. Perhaps you're writing a test suite for such a library and find that testing code a tedious task, or maybe you've written a program that you could use an extension language and you don't want to design and implement a new language for your application. Python is just a language for you. Okay. You could just write a Unix shell script or Windows batch files for some of these tasks, which I do, but the shell scripts are best at moving around files and changing text data, not well suited for GUI applications or games, okay? You could write a C or C++ Java program, but it could take a lot of development time just to get a first draft program. Python is simpler to use, available on Windows, Mac OS, and Unix operating systems, and will help you get the job done more quickly. Python is simple to use, but it is a real programming language, offering much more structure and support for large programs than shell scripts or batch files can offer. On the other hand, Python offers much more error checking than C, and being a very high-level language, it has high-level data types built in, such as flexible arrays and dictionaries. Because of its more general data types, Python is applicable to a much larger program domain than awk or even Perl, yet even these many things are at least as easy in Python as in these languages. Python allows you to split your programs into modules that could be reused in other Python programs. Comes with a large collection of standard modules. Hang on a second. Let me adjust the volume here. Let me turn that down a bit. That's better. All right, so you could split your program into modules. Some of these modules provide things like file I/O system call sockets and even interfaces to graphical user interface toolkits like TK. Interpreted language could save you considerable time during program development. Because no compilation and linking is necessary, the interpreter can be used interactively, which makes it easy to experiment with features of the language, to write throwaway programs or to test functions during bottom-up programming development. Is also a handy desk calculator. Okay. enables programs to be written compactly and readably. Programs written in Python are typically much shorter than equivalent C, C++, or Java programs for several reasons. The high-level data types allow you to express complex operation in a single statement. Statement grouping is done by indentation instead of beginning in any brackets. No variable or argument declarations are necessary. Python is extensible if you know how to program in C, which I do. It is easy to add new built-in function or module to the interpreter, either to perform critical operations at maximum speed, or to link Python programs to libraries that may be only available in binary form, such as in vendor-specific graphics libraries. Once you're really hooked, you can link the Python interpreter into an application written in C and use it as an extension or command language in that application. By the way, the language is named after the BB-SO, the Monty Python's Flying Circus, and has nothing to do with snakes or reptiles. Okay, making references to Monty Python skits in documentation is not only allowed, it's also encouraged. Righto. So now that you are all excited about Python, you'll want to examine it in some more detail, since the best way to learn a language is to use it, which is what we're going to do today. The tutorial invites you to play around with the Python interpreter as you read. In the next chapter, the mechanics of the interpreter are explained. This is rather mundane information, but essential for trying out the examples shown later. The rest of the tutorial introduces various features of the Python language and system through examples, beginning with the simple expressions, statements, and data types, through functions and modules, and finally touching upon advanced concepts like exceptions and user-defined classes. Okay, let's move on. Next topic, using the Python interpreter. The Python interpreter is usually located at this location on these machines where it's available. Putting user bin local in your Unix shell search path makes it possible to starting. Okay, yeah, so hang on a second. Let's start the console. Console. View. So I don't normally use VS Code. I need to find where that console feature is. Huh. Well, we got a terminal. Let's see. So you could just use the py command. So what if I just say py? Py is not recognized. Exit. Py. Oh. The term py is not recognized. Okay. Is it installed? Are the paths all set up? I thought I set up the paths. Python 3.14. No? Hold up. Let me take a look at my setup. Python. Where did it even install? I am checking on where the file locations are. Open file location. Okay. So it appeared that Python is located in this directory here. So now I need to check where my paths are. Because 3.14.exe. Just try Python. Oh. Okay, let's see. Where are my paths? CD echo path. I'm doing this off screen because there could be some private information. Let me do this off screen. So supposedly, see users normal. Huh. CMD echo path. Is this a hole? Hang on. Is Python in here? I see some Python stuff here. But am I missing something? Python. No. If I say okay, let's try this. Set path and then we say this. Does that work? Huh? Environment variable not defined. Or did I do it backwards? Set. Oh, so the format is set variable is equal to string. Okay. So you say set path is equal to path semicolon the path I want to add. So then I say Python Python Bro, I'm hitting a brick wall here. What's going on here? Does chat have any thoughts? Is anybody even here? No feedback from the chat. Okay. Let's just keep grinding here. Could just start with the idle shell. We got an idle shell, and what else came with it? Because if I click here, this is also similar. I'm guessing that this thing has more features. Right, let's just try the idle shell. So since the choice of the directory where the interpreter lives is an installation option, other places are possible. Check with your local Python guru or system administrator. If you have the PyLauncher installed, you can just use a py command. Python. Typing the name of the character at the primary prompt causes the interpreter to exit with a 0 exit status. If that doesn't work, you could exit the interpreter by typing the following command: quit. So if I say quit, boom, your program is still running. Do you want to kill it? Yep, well that works. Okay, the end of the... No, I'm joking. All right, let's see. So let's reload idle. So I'm not entirely sure why the console isn't working with Python. Let's see. All right. So why did my computer decide to minimize everything? I don't know. Okay, so my question is how to, or we could say set up VS Code Python console. La 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 la. Okay, we got the Python interpreter. Okay. If I say Pi 3 version, Pi. So where's Pi? Huh? Pi. Huh? Okay, well I got it to work off screen. Let's start this over. We say exit. Pi. So Pi is not recognized, and I don't know why. Where is Pi? Start VS Code in a workspace folder. All right, let's take a moment to focus on VS Code because I'm having trouble setting up this environment here. Bear with me. Any feedback in the chat would be appreciated. All right, so it says Windows, open the command prompt and run the following command, Pi 3 version. So if I do so here's a command prompt, Pi 3 version. See, it's working here. Try the same thing. Pi 3 version. So it's working here. Echo path. All right, what do we have here? Verilog, DDE. Hang on a second. Got this thing called Python Launcher. So I wonder if this is it. Is that where Pi is? Check that out. Yeah. So this is probably what we're looking for. So VS Code Pi does not start in console. If your Python code is not starting in the console when using Visual Studio Code, ensure that you have Python extension installed, check, and that your terminal settings are correctly configured. So what kind of settings? Open your launch JSON file and confirm it's correctly set up for Python debugging. How? Where is the launch JSON file. It's typically located in the VS Code folder within your project directory. Here's how to find it. Oh, is that the problem? Is that the problem? Is that I have to create this whole configuration file? Maybe what I need to do is I need to start over here. So here, let's close the console, close the terminal, start over. Let's see. Okay, you would say VS Code Python folder template. This repository contains sample code illustrating various Python-related projects and their recommended configuration. Each sample is a self-contained scenario that provides a recommended project configuration and some sample code to get you started. You can read, play with, or adapt from these samples to create your own projects. Git clone. Huh. Okay. Do I even have Git installed? I don't think I do. Or maybe I do. Oh, I think I did. I think I did install it a while ago. So like, for example, just a basic script. File, open folder. Is this really necessary? Hang on a second. VS Code, Python. Setup. Quick start. Oh. I mean, so this is working from the terminal. So far so good, but this is where things get complicated. By starting VS Code in a folder, that folder becomes your workspace. Using a command prompt or terminal, create an empty folder called hello, navigate into it and open VS Code in that folder by entering the following commands. You know what? I'm going to clear this out. Okay, ready? We're going to do nice and clean. Here we go. CD. We're doing this old school method. Ready? No more Mr. Nice Guy. CD. Repos. Let's see. How about okay, what was I doing? I have to move this off the stream. Hang on a second. CD here. Okay. Right, anyways, cd, we're going to do the thing where we make a directory. Make dir hello. There it is, right? cd hello. Then we just type code dot. And what does it do? It opens up VS Code in that directory. I am the author. I trust the authors. Okay. If you're using an Anaconda distribution, we are not. All right, so we create a virtual environment. A best practice among Python developers is to use a project-specific virtual environment. Once you activate that environment, any packages that you then install are isolated from other environments, including the global interpreter environment, reducing some implications that arise from conflicting package versions. You can create non-global environments in VS Code using Venv or Anaconda with Python create environment. Okay, is that really necessary? Open the command palette, Control-Shift P. Okay. And start typing the Python create environment command to search, and then select the command. The command presents a list of environment types, Venv or Conda. For this example, select Venv. Okay. The command then presents a list of interpreters that can be used for your project. Select the interpreter you installed at the beginning of the tutorial. In this case, that would be Python 3.14. So now it's creating an environment. Okay, cool. The following environment is selected. Okay. After selecting the interpreter, a notification will show the progress of the environment creation, and the environment folder Venv will appear in your workspace. Speaking of which, oh, there it is. Cool. Ensure your new environment is selected by using the Python select interpreter command. Python. From the command palette. Where's the command palette? Is that the command palette? What? Hang on. Oh. Control-Shift-P. I have to do Control-Shift-P to do the command palette. Okay, so we say Python select interpreter. Okay. For additional information about virtual environments, or if you run into an error in the environment creation process, the environments. Okay. From the File Explorer toolbar, select a new file on the Hello folder. I guess I mean this one. Boom. And we will call it hello.py. Nice. By using the .py file extension, you tell VS Code to interpret this file as a Python program, so that it evaluates the contents with the Python extension and the selected interpreter. Right. So now that you have a code file in your workspace, enter the following source code in hello.py. All right, message is equal to roll a dice. Then you say print message. Great. When you start typing print, notice how IntelliSense presents some auto completion options. Print values object. Cool. Yeah, I can see that. IntelliSense and auto-completions work for standard Python modules as well as for packages you've installed into the environment of the selected Python interpreter. It also provides completions for the methods available on object types. For example, because a message variable contains a string, IntelliSense provides string methods when you type message dot. Oh, check it out. So if I say message dot, so I could capitalize, I could case fold, center, count, encode, end switch, expand tabs, find, format, map, index, blah, 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 blah. Is lower, is numeric, is printable, is space, is upper, join, lower, else strip, blah, blah, blah. Replace, hard find. Yeah, there's a lot of stuff you could do. Cool. Finally, you could save the file with Control S, and at this point you're ready to run your first Python file in VS Code. For full details on editing, formatting, or refactoring, see editing code. The file extension also has supports for linting, right? So we run the Python code. Oh, hey, now there's a little play button. Ah, so what did it do? It just printed out the words, roll a dice. Roll a dice. Cool. It hardly does anything, but cool. The buttons are turned up. By the way, hang on a second. As I say hi. See, now it works. See, I had this up in the environment, I guess. Quit. Yeah. Python button opens the terminal panel and the Python interpreter is automatically activated, then runs Python 3 hello.py or Python hello.py windows. Righto. So it says roll dice, which it did. There are 3 other ways you can run Python code within VS Code. Right click anywhere in the editor and select Run Python. Where? Anywhere in the editor? Oh, there it is. Run Python file on terminal. There it is. Roll a dice. Yep. Which saves the file automatically. Okay. Select one or more of the lines and press Shift Enter or right click and select Run Python run selection line in Python terminal. Alternatively, you could activate the Smart Send using Shift Enter without a selection, and then the Python extension will send the smallest runnable block of code where you... Okay. This command is convenient for testing just part of a file. So if I, for example, print this is a different piece. This is just one piece of code. Right, so if I select this on its own, right? And then I say run selection line in Python terminal. There it is. So it just put it in the REPL. Quit. Okay. Note, if you prefer to send code at this particular line your cursor is placed, you can turn off Smart Send by setting Python blah 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 to false in your user settings. Oh, whatever. From the command palette, select Select the Python. Start terminal REPL. Okay. Python. Start terminal REPL. What's the difference between that and the native Python REPL? Don't know. But we start it. And what was it do? What did it do? Did I click wrong? I don't see the REPL. Where's the REPL? Exit. Huh. Let's try it again. So if I say Python, oops. So it's Control-Shift-P. I gotta get used to this. Start terminal REPL. There's a REPL. Print. Hi, Mom. Hi, Mom. Works for me. Quit. Exit. All right. Any lurkers in the chat? Any lurkers in the chat? No? If you're lurking, type something. What are we doing here? I don't think we have any lurkers. Oh well, moving on. All right, what's next? Configure and run the debugger. Ooh. Let's try debugging our Python program. Debugging support is provided by the Python debugger extension, which is automatically installed with a Python extension. Good. To ensure it has been installed correctly, open the extensions. Open the extensions menu. There it is. I already have it installed. Set a breakpoint on line 2 of hello.py. Boom. There's a breakpoint. By placing the cursor on the print colon, pressing F9. Alternatively, click in the editor's left gutter, which I did, next to the line numbers. When you set a... wait, so you hover it and then you... What? By placing the cursor on the print call and then pressing F9. You sure about that? I do the gutter method. That seems to work. Okay. Not sure why it says it doesn't seem to work. But anyways, I've always done the gutter method anyways. To initialize the debugger, press F5. Since this is your first time debugging this file, the configuration menu will open in the command palette, allowing you to select the type of debug configuration you would like to use for the open file. Select Python file, which is a configuration that runs... Python file? What? Don't you mean Python debugger? Let's just do Python debugger. Oh, Python debugger and Python file. There we go. See, it tripped up right here. Select Python file, which is a configuration that runs a current file shown in the editor using the currently selected Python interpreter. The debugger will start and then stop at the first line of the breakpoint. The current line is indicated with an arrow, yellow arrow on the left margin. If you examine the local variables window at this point, you will see that the message variable appears in the local pane. Where? Oh, here. So it says that message is roll a dice. Useful. A debug toolbar appears along the top with the following commands from left to right. To continue is F5. Step over is F10, step into is F11, step out is Shift F11, restart is Control Shift F5, and stop is Shift F5. The status bar also changes color. Orange and many themes to indicate that you're in debug mode. The Python debug console also appears automatically in the lower right hand panel. Blah blah blah. To continue the program, select the continue command on the debug toolbar. Boom. See, it said roll a dice, and then this is just one piece of code. So, yeah. Debugging information can also be seen by hovering over code, such as variables. In the case of message, however, hovering over the variables will display a string roll the dice in a box above the variable. You can also work with the variables in the debug console. If you don't see it, select debug console in the lower right area of the VS Code, or select it in the ... menu. Then try entering the following lines one at a time at the thing prompt over here. Huh? Let's see. Is it? What am I looking at? Wait. You can also work with variables in the debug console. So what? Am I supposed to go into debug mode and then type it in the console? So where's the debug console? Okay. Here's the debug console. Okay. So in the debug console, I could say MSG. Boom. Ah. Okay. Now I get it. I could say MSG.capitalize. Whoops. Roll a dice. I mean, what did it do? Capitalize the first letter? MSG dot all. Upper? Ah, there we go. That makes it full uppercase. MSG.lower makes it all lowercase. MSG.capitalize in turn just uppercases the first letter. Now if I make it MSG.split, that's a little special. Roll. It turns it into an array of space separated words, I guess. But notice that there's a exclamation point after dice, and that was integrated. Is there a merge? MSG merge? Join? Let's try join. No. Well, I don't know. Yeah. Anyways, it looks like there's a lot of features here. Cool. So let's see if I say step over. Where's the output? Wait. Okay, so I don't know what happened here. I'm just gonna check something real quick. Hang on. Select the blue continue button again, and I'll just keep going. Okay, I don't know what's going on here. Exit. So if I do the debugger again, so what happens? So it pauses there. Click that. There we go. Right, where were we? Select the continue button on the toolbar again to run the program. Roll dice appears in the debugging console. If you switch back to it, and VS Code exits debugging mode once the program is complete. If you restart the debugger again stops on the first breakpoint. To stop running before it's complete, use a red square stop button. Okay, that's the usual stuff. Install and use packages. Let's build upon the previous examples by using packages. In Python, packages are how you obtain any number of useful libraries, typically from PyPole, that provides additional functionality to your program. For this example, use a numpy package to generate a random number. Okay. Return to the Explorer view, which I guess is here. Open hello.py and paste in the following source code. Right, let's just replace it like so. Okay, so it's telling me to run it even though I don't necessarily have it installed. So let's see what happens. Trace back. No module named numpy. Right, so if you should see the message module not found error, no module named numpy. Yep. This message indicates that the required package isn't available in your interpreter. If you're using Anaconda distribution or have previously installed the numpy package, you may not see this message. To install the numpy package, stop the interpreter, stop the debugger, and use the command palette to run terminal. The command palette. Create new terminal. Exit. So we do command palette. Let's see. Create new terminal. I'm guessing we mean with profile. Let's just stick with it. This opens up a command prompt for your selected interpreter. What is our selected interpreter? You got Bash, you got PowerShell, you got Windows PowerShell. Does it matter? Right, so we have to install the package. So on Windows, we type pip install numpy. So this should give us the numpy library. Right? So we just downloaded numpy and we installed it. There it is. So now we could rerun the program to view the output. So if I press F5, that'll run the debugger. Oh yeah, I guess I don't need that there. Right, so what it did was it printed roll of dice, and then it did a random integer from 1 to 9, I'm guessing. And that's what it printed. Did it again. Now it's a 2. Yes, so it says right here. First you give it the lowest number, then you give it the highest number. Roll dice. 2, 3, 4, 4, 7, 3, 7, 5, 8, 1, 7, 6, 7, 2, 2, 8, 3, 5. We're gonna get a 9? Let's get a 9. 2, 7, 5, 2, 4, 7, 5, 5, 1, 3, 7, 5, 4, 5, 4, 3, 5, 1, 4, 2, 3, 3, 4, 6, 8, 3, 6, 7, 5, 4, 7. It didn't go up to 9. 1, 5, 3, 8, 2, 8, 8, 2, 2, 8, 7, 7. Oh. It's in the half open interval. Right. So it looks like the highest we got was an 8. Managing dependencies across environments. When working on Python projects, it's essential to manage your dependencies effectively. One useful tip is to use the pip freeze requirements command. This command helps you to create a requirements file that lists all the packages installed in your virtual environment. This file can be used to recreate the same environment elsewhere. Follow these steps to create a requirements.txt file. So I'm in the PowerShell, right? So I say so we say .venv Am I understanding this correctly? I think that's an error. .venv. Then we say scripts. Activate. Okay, so what did that do? Follow these steps to create the requirements file. So first you run that batch script, yeah, which I did. And then generate the requirements file. So we say pip freeze requirements txt. Right, so if I look here, it says that we now require numpy 234. Cool.
Life doesn't wait, and neither should you.
You can now use a newly generated requirements.txt file to install dependencies in another environment. Furthermore, if you continue to add dependencies as your project may grow incompletely, pip install our requirements. By following these steps, you ensure that your project dependencies. So I could do this, and I would say pip
to you.
Install
Use as directed.
our requirements.txt. Requirements already satisfied. There you go. During the course of this tutorial, you learn how to create a Python project, create a virtual environment, run and debug your Python code, and install Python packages. Yup. I will keep this tab handy while I go through some of the tutorials here. Right. So, exit. Just loaded so many terminals. Sure. So click that, and I want to do PowerShell, let's say, for example. The interpreter's line editing fee. Okay, so let's just revisit what this is. It's called using the Python interpreter. Wait, exit, because we're talking about the REPL. So if I say Control-Shift-P, no, and I just click Start Terminal REPL. So now I got the REPL. Let's take a look at what's going on here. Can we make that bigger? Maybe. But there's the prompt. So now that we've already familiarized ourselves with the VS Code environment, we could kind of start playing around with this tutorial a little bit more realistically. Right. The interpreter's line editing features include the interactive editing, history substitution, and code completion on systems that support the GNU readline library. Right. Argument passing. When known to the interpreter, the script name and additional arguments thereafter are turned into a list of strings and are assigned the argv variable in the sys module. You can access this list by executing import sys. The length of the list is at least 1. What if I say print sys? When no script and argument is even given. Sys.argv 0 is set to dash. Oh. Got it. So it looks like there's a way to pass arguments into Python from any kind of a scripting environment. Argument passing. When known to the interpreter, the script name and additional arguments thereafter are turned into a list of strings and are assigned the argv variable in the sys module. Then you got interactive mode. When commands are read from a TTY, the interpreter is said to be in interactive mode, which is what we see right here. Right. In this mode, it prompts for the next command with the primary prompt using the 3 greater than signs that you can see here, followed by, for continuation lines, it prompts with the secondary prompt with 3 dots by default. The interpreter prints a welcome sign, welcome message stating its version, and a copyright notice before printing the prompt. Continuation lines are needed when entering a multi-line construct. As an example, take a look at this if statement. So we say, the world is flat. True. Okay. If the world is flat, colon, print. Be careful not to fall off. Oop. Keyboard interrupt. Huh? Hang on a second. Oh, I was supposed to press enter again.
You probably know Vistaprint for business cards, but did you know we print everything you need to get your brand in front of your fans? We print banners and signs that help your business stand out. We print postcards and flyers that get people talking. And we print must-have merch like tote bags, t-shirts, and water bottles. Whether you want a few or a few thousand, we print on everything so that customers can go from noticing your brand to falling in love with it. Right now, new customers can get 20% off.
There we go. So you can see for more on your active mode, see your active mode. Interpreter as environment. Source code editing by default. Python source files are treated as encoded in UTF-8 in that encoding characters. Most languages in the world can be used simultaneously in string literals, identifiers, and comments, although the standard library only uses ASCII characters for identifiers, a convention that any portable code should follow. To display all these characters properly, your editor must recognize that the file is UTF-8 and it must be used a font that supports all the characters in the file. To declare an encoding other than the default one, blah 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 blah. Yeah, I don't care about that. Okay, what else? Let's see. Oh, we already did that. Okay. Next topic, an informal introduction to Python. In the following examples, input and output are distinguished by the presence or absence of prompts. To repeat the example, you must type everything after the prompt. When the prompt appears, lines that do not begin with the prompt are output from the interpreter. Note that a secondary prompt on a line by itself is an example. Means you must type a blank line. This is used to end a multi-line command. You could use the copy function. It appears in the upper right corner when hovering over or tapping out. A code example which strips out prompts and omits output to command. Okay. Here's an example. This is not easy to read. Why is that? There we go. So, this is first comment. Yep. Spam. And this is the second comment. And now a third text is equal hash. This is not a comment because it's inside quotes. Which, by the way, if I say print span, it gives me 1. If I say print text, this is not a comment because it's inside quotes, of course. Using Python as a calculator. Let's try some simple Python commands. Start the interpreter and wait for the primary prompt. Shouldn't take long. Well, I'm already in it. Numbers. The interpreter acts as a symbol calculator. You could type an expression at it, and it will write the value. Expression syntax is straightforward. The operators plus, minus, times, and divide can be used to perform arithmetic. Parentheses can be used for grouping. For example, 2 plus 2 is 4. 50 minus 5 times 6. Okay, is 20. 50 minus 5 times 6. Divided by 4. It's 5.0. 8 divided by 5. And there's a comment. Division always returns a floating point number. It's a little bit different between that and, say, C and C++. They say they do an integer division, which is not the same thing. So the integer numbers, e.g. 2, 4, 20, have type int. The ones with the fractional part will have type float. We'll see more about numeric types later in the tutorial. Division always returns a float. To do floor division and get an integer result, you could use a double... Wait. To do floor division, what's floor division? Mathematical division that rounds down to the nearest integer. Oh. The floor division operator is... Oh, okay. So that's how you do the... For example, the expression 11 integer division 4 evaluates to 2 in contrast to the 2.75 returned by the float true division. Note that negative 11 integer division 4 is negative 3 because negative 2.73 is rounded downwards. That is a lesser number, so negative 3 is less than negative 2.75. Yep. Any nerds lurking in the chat? Yeah, moving on.
Longing for lazy summer days in Santorini or a dreamy
Okay,
drive
where are
down
we?
the Blue Ridge Parkway in the fall? With an annual plan from Allianz Travel Insurance, you can choose both. Be ready to go year-round, whenever Wanderlust strikes.
Where were we?
Without the ones like you working tirelessly to keep things running, everything would suddenly stop.
Division always returns a float. To do floor division and get an integer. Okay, so let's just try this. So we say 17 divided by 3, 5.6, 17, double divide 3. So that's the floor division. 17, 3, that's 2. 5 times 3 plus 2. Floor quotient divisor remainder. Yep. With Python, it's possible to use the double times operator to calculate powers. Ah. So 5, 2 is 25, of course. 2 to the 7th is 128. The equal sign is used to assign a value to a variable. Afterwards, no result is displayed before the next interactive prompt. So, if for example we say width is 20, height is equal to 5 times 9. So we say width times height is 900. If a variable is not defined or assigned a value, trying to use it will give you an error. So I say n, nope, there's no n. There's full support for floating point operators with mixed type operands. Convert the integer operand to a floating point. 4 times 3.75 minus 1, which is 14, right? Yep. In interactive mode, the last printed expression is assigned to the variable underscore. This means that when you are using Python as a desk calculator, it's somewhat easier to continue calculations. For example, tax is equal to 12.5 divided by 100. Okay. Price is equal to 100.50 price times tax. And then we say price plus underscore, which means the last one, meaning your total is 113.0625, but we want to round that. We want to round the previous output, which will be round underscore. I'm guessing that's a second decimal point. Cool. 113.06. This variable should be treated as a read-only by the user. Don't explicitly assign a value to it. You would create an independent local variable with the same name, masking the built-in variable with its magic behavior. In addition to int and float, Python supports other types of numbers such as decimal and fraction. Python also has a built-in support for complex numbers and uses a J or J suffix to indicate the imaginary part. Oh, cool. So if I say 3 plus 5j, yep. Python can manipulate text represented by the type str, so-called strings, as well as numbers. This includes exclamation point, words rabbit, names Paris, sentences, got your back, etc. They could be enclosed in single quotes or double quotes with the same result. For example, if we say spam eggs, Paris rabbit got your back, smiley face, exclamation point, yay. Right. And then 1975. To quote a quote, we need to escape it by preceding it with a backslash. Alternatively, use using the quotation marks. Ah. So for example, we say doesn't yes, comma, they said. Yep. And then what's this? I'm just so used to see this. This might actually make more sense to me mentally. Yes, comma, escape. They said. Yep. Then you got is.
It's not what you make, it's what you keep. Patriot Software can lower your costs for accounting and payroll software. Keep your money in
They
your
said.
Keep your time and
Yep. No. No. Wait. You're just BSing me. I wasn't paying attention. Okay. Freaking me out, dude. In the Python shell, the string definition in the output string can look different. The print function produces a more readable output by omitting the enclosing quotes and printing escaped and special characters. So I could say S is equal to first line \n second line. Okay. And then I just type S. Without print, special characters are included in the string. Huh. But if I print it, print S. There we go. It actually prints it properly. First line, second line. Righto. Let's try something different. Hang on a second. La, 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 la. Okay, somebody came in and said, "Hey brother, can I ask a general question?" Yes, you can ask a general question. What's your general question? When did this come in? Why do people just come in with questions and then don't ask? Just ask your question. Bro. Let's find this guy's stuff. Okay, we got a chatter asking for a question and then he just disappears. I don't like when people just disappear. There's a reason why I got the chat up, it's so I can interact with you guys, and then you just flee. Though, to be fair, I don't know when he asks a question. Is he even still here? Well. Let's see. Paint. I'm about to do something forbidden. It'll mess with the sound a bit. There we go. Oh, here it is. Any tips for writing Python and pushing the Raspberry Pi? I'm trying to get an audio engine going. Let's see. Why didn't it go to the... I don't understand why the chat didn't make it to my my overlay. Oh, there it is. It must have just came in. Oh, there we go. Right, because I've only been more involved in the C++ side. This is actually my first foray into Riff, and just messing around a bit. Because if you look at what I've done so far in the stream, I've just barely gotten my VS Code up and running, and then now I'm just going through the basic tutorial from Python. So that's where I'm at now. If you're talking about audio engines, I mean, wouldn't you want to write your audio engine something more like C++ or something a little bit more low level? Because the thing about audio engines is that you want to be low latency, right? Now, of course, if you're prototyping, sure. I guess my first thought would be, if you're doing rapid prototypes, before you even think about putting on a Raspberry Pi, just get it working in the first place. Like, make your prototype, make sure it's playable, like you could play it back, like you could process your data and you're getting predictable results, but you gotta do your prototype. I would say do your prototype on a desktop before you think about retrofitting it on, say, a Raspberry Pi, right? Those are my initial thoughts, so I haven't really gotten into audio engineering myself. Was that helpful? Right. Anyways, I think I need to take a quick coffee break. Let's see. Coffee. I figured out how to connect my desktop and the Pi via SSH. Yep, that works. It's helpful. Very good. Be right back. Okay. Just give me a sec. I'm back. I'm back. All right. Where were we? I just grabbed a cold brew draft latte that my wife got from Costco. This one is peppermint mocha flavored. And we're just kind of getting, for those who are just tuning in, we're just kind of getting into the nuts and bolts of Python. So again, I have more of a C and C++ programming background, and I'm just taking a look at this for the first time ever. But I just set up the VS Code environment, and I'm just kind of doing the basic tutorials to kind of familiarize with myself with the Python, and you get to see my mind at work live. So cheers. Tastes like Christmas. It is peppermint mocha flavored after all. Pull up my OBS so that I don't miss anything. Any other questions are definitely welcome. Let's see. Here. Your questions are welcome here. Welcome. Q&A. Feel free to ask any questions. There we go. There we go. Where were we? Okay, so we just did this print versus entering a string in the REPL. The difference.
Well, I was down on my last dollar and then I started saving because the bank said fiscal restraint is what you're craving. So I put my earnings in a high yield.
Oh, so if you don't want characters prefaced by the backslash to be interpreted as special characters, you could use raw strings. What the heck?
Boring money moves make
I don't
you
like that.
lame songs, but they sound pretty sweet to your wallet. PNC Bank.
You can use raw strings by adding R before the first quote. Oh, let's see. So I could say MSG is equal to R. There's one subtle aspect to raw strings. A raw string may not end in an odd number of backslash characters. What? Huh. So we would say, let's just do the example. Print C : backslash some name. What? Syntax warning. So it doesn't talk about the syntax warning here, but anyways, it did the new line. So it does C : backslash some and then aim. But whereas if I use the raw string, print end just like that. Now, why was it talking about the even number of backslashes? Some name foo. May not end in an odd number of backslash characters. Oh, so if I do this, there we go. Unterminated string literal detected in line 1. So if I do this, well, that's a little interesting. Is it not possible to end a raw string with a So, okay. Then you got string literals. They can span multiple lines. One is using triple quotes or triple quotes like this. And then the characters are backslash at the end of the word. So in this case, this is actually not part of the string. So I could say, message is equal to, and then I'll do the backslash. Hello there. My name is Kathobrowski. E. And then how do you... Oh. And then I say print message. Because I ended it with an extra new line at the end. Right. Strings can be concatenated or glued together with a plus operator and repeated with x or times with the asterisk. So I could say so if I say ba plus na times 2. Oh, that didn't work. Oh, I know why. Ba na. So what is that? Banana. Banana. Cool. So if I say 3 times un plus ium unununununium, and then 2 or more string literals, i.e. the ones enclosed between quotes next to each other, are automatically concatenated. Okay. Python is Python. All right. This feature is particularly useful when you want to break two long strings. Text is equal to put several strings within parentheses to have them joined together. Okay, then I'll click, just type text. What did I? Oh, I wrote text and I wrote test instead of text. But I could do this. Text is equal to test, and then I type test. Put several. I spelled strings wrong. Put several strings within parentheses to have them joined together. Okay, cool. Right. This only works with two literals, though, not with variables or expressions. So we say prefix, excuse me, prefix is equal to pi, okay, prefix thon. Well, of course, I know what this does. Oh, whoops. Oh, can't concatenate a variable and a string variable. Okay. So it only works with literals, not with variables or expressions. I didn't even read that. Okay, same thing with union. Why not? If you want to concatenate variables with a variable, we'll use the plus. Okay. So let's do the union method right here. You could say un times 3 plus em. Oh no, there we go. Isn't we didn't we do that before? I'm just gonna check my Rumble chat because I don't have an overlay for that. Nope, nobody's in my Rumble chat. Moving on. If you want to concatenate variables or a variable in a literal, use plus. Prefix plus thon. Okay, we already talked about that. Strings can be indexed, subscripted with the first character having an index 0. Yeah, as if I could remember which languages always start with the 0. There is no separate character type. A character is simply a string of size 1. Sorry, my wife is texting me. Hang on a second. Right. Okay. Where were we? So if we say word is equal to Python So word 0 is the 0th element, which is the first element. P. What about 1? Should be Y. Y. And then it says indices may also be negative numbers to start counting from the right. All right. So if I say -1, so -1 means the last character, meaning you start here and you go back 1. I guess that kind of works. Right. -2 is O. Okay. Note that since -0 is the same as 0, negative indices start from -1. Right, anyways. In addition to indexing, slicing is also supported. While indexing is used to obtain individual characters, slicing allows you to obtain a substring. Right, so word 0, 2. Now what does that mean? It says right here. Characters from position 0 included to 2 excluded, and then characters from position 2 included to 5 excluded. Yeah. Because if I do the same thing, 2 to 5. Yep. Thol, Python, Python, Python. Python. See. Any lurkers in the chat spam my overlays? Spam the chat. I don't think there's anybody here. I don't mind a little time with the void. Alright, what do we got here? So since slices have useful defaults, an omitted index defaults to 0, and omitted second index defaults to the size of the string being sliced. So for example, word :2, it's like that. Pi. Sure. Word 4 : on. So :2 means up to position 2. So they'll give you the first 2 characters. Huh. Word 4 : So if I say I want to skip the first 2 characters, I would say word 2 : What if I do something stupid and I say 10? It just doesn't give you any errors. It just gives you a blank string. Okay. No exceptions. That doesn't throw an exception. Okay. Goody. Note how the start is always included and the end is always excluded. This makes sure that S is always equal to S. So if I say word 3 word 3 Python. But if I add them together, word 3 plus word 3 is Python. Yep. Right, so one way to remember how slices work is to think of the indices as pointing between the characters with, I think I figured that out, is with the left edge of the character number 0, then the right edge of the last character of the string of n characters in index n, for example, Python, so it's 0 to 6, right, position 0, position 6, -1, -2, -3. So if I say, this is why, no, that all makes sense. So the first row of characters gives a position of indices 0 to 6 in the string. The second row gives the corresponding negative indices. A slice from I to j consists of all characters being between the edges labeled I and j respectively. For non-negative indices, the slice of the length of a slice difference is the difference of the indices if both are within bounds. For example, the blah, 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 is 2. Yep. Attempting to use an index that is too large will result in an error. However, out-of-range slice indexes are handled gracefully when used for slicing. Oh, right, because I noticed that earlier. Because if I try to say word of 40, there's obviously not 40 characters. Ah! Error! Yep. So Python strings cannot be changed. They are immutable. Therefore, assigning an index position in the string results in error. Well, really? Why? If you need a different string, you should just create a new one. What the heck? I could do this in C++. I could do this in C++. It won't let me change the strings? Okay. So the appeal was supposed to be that Python is easier, gives you shorter. You're just creating rules here? Okay. Whatever. Because if I say word of 0 is and I say J, and it would object to that, of course. The built-in function. So, okay, because I could concatenate something like this to create I could make a thing called word2. Whoops, word2 is equal to J plus word of 1 : like that. So if I say word2 is Jython. And of course, you could always get the length of your strings. Length of word2 is this. Something. Righto. There's a bunch of other cross references here, and then we got lists. Python knows a number of compound data types used to group together Other values, the most versatile is a list, which can be written as a list of comma-separated values between square brackets. Okay. Hints of C here. So we say squares is equal to 1, 4, 9, 16, 25. I probably could have calculated that, but whatever. So if I type squares. But now let's try it this way, because I just remembered something from something else. I could say squares is equal to 1, 2, 2, 2, 3, 2, 4, 2, 5, 2. Right? And then it'll be the same thing. Yep! Because that means 1 to the power 2 is 1, 2 to the power 2 is 2, 3 to the power 2 is 9, 4 to the power 2 is 16, and 5 to the power 2 is 25. Yep. Learn something new every day. Like strings and all other built-in sequence types, lists can be indexed and sliced, of course. I'm not gonna type these out. Lists can also support operations like concatenation, of course. Unlike strings, which are immutable, lists are immutable type. Okay. See, the strings are not mutable. I mean, is there a... I don't need to get hung up on this. Let's just keep going. Lists also support operations like concatenation. So I could even do things like this where I say squares, or I could say more squares is equal to squares plus, and I would say 6, 2, comma, 7, 2, 8, 2, 9, and 10 to the power 2. Because if I say more squares, one, 4, 9, 16, 25, 36, 49, 64, 81, 100. Unlike strings, which are immutable, but I could change the content. Huh. So somebody manually enters these 5 cubes and somebody notices that the second one is, that one of these is wrong, so you could just fix it. It's mutable, right? See, here's the thing. In C, a string is just simply an array of characters, and it's mutable. They decided to make strings immutable. Somebody did it for a reason. I don't know what that reason is. Well, you can also add new items at the end of the list by using the list append method. We'll see more about the methods later. Right. So I could say more squares append 11 2. There it is, 121. Then you got 12 2. There you go. Simple assignment in Python never copies data. Huh? Simple assignment in Python never copies data. When you assign a list to a variable, the variable refers to the existing list. Any changes you make to the list through one variable will be seen through all the other variables to it. Oh. So how do you make a copy list? How do you make a copy of a list? Well, moving on. So here you see that a change is being made. This is an example where you got this list called RGB. So you make this new list called RGBA. Actually, it's not a new list, it's a new reference to the same list. ID. What is ID? Identification. So when you say ID, as in are they the same references? Identification. So that's kind of like an address in C. But the question is, are they the same ID? Are they the same reference? So if you say if I make a thing called more squares 2 is equal to more squares, then I would say ID, why did I use such a long name? More squares is it the same as the ID of more squares 2? The answer is yes. But what about squares? It should say no or false. Yeah, that's false. All slice operations return a new list containing the requested elements. This means that the following slice returns a shallow copy of the list. Whoa, I have questions. So if I say RGBA is equal to red, green, blue, alpha, right? Here's my question. If I say GBA is equal to one colon like that. Whoop. Oh, RGBA. There we go. And then I say GBA is green, blue, alpha. And then I say GBA, the first element is green. So if I say GBA underscore green, now what's RGBA? Right, green. Okay. So it looks like they're I don't know what it means by shallow copy. What's a shallow copy? Shallow copy. A shallow copy constructs a new compound object and then, to the extent possible, inserts references into it to the objects found in the original. A deep copy constructs a new compound object and then recursively inserts copies into it of the objects found in the original. Two problems often exist with deep copy operations that don't exist with shallow copy operations. Recursive objects may cause a recursive loop because deep copy copies everything. It may copy too much, such as data which is intended to be shared within copies. Deep copy function avoids these problems by keeping a memory directory of objects already copied during the blah, blah, blah. Okay. So in general, it sounds like shell copy is generally lighter weight. Right? Assignment to slices is also possible, and this could even change the size of the list or clear it entirely. Letters A, B, C, D, E, F, G, sure. And then 2 through 5. You could replace some values. What? That's interesting. Let's see. I'm feeling lazy. Copy paste. Yep. So if I say letters, boom. Here's a question. Can I shorten the list by doing this? Letters is equal to letters 2 colon like that. Yes, it does work. And I could even do this. Letters 0 colon no 1 colon 2 1 colon 3 is equal to y y and z. Did that work? Letters. There's Y and Z. Then there's F and G. And then it said I could do this. Clear the list like that. Oop. Oh, this is a syntax it uses. So I say letters, the full range is blank, like so. Boom. So then letters is nothing. It's absolutely nothing. It's empty. There are no letters. So you could use the len function on lists. Great. It's also possible to nest lists, create lists containing other lists. So here's a list of letters, then numbers, then... Huh? Oh. What? Right. First steps towards programming. Of course, we can use Python for more complicated tests and adding 2 and 2 together. For instance, we could write an initial subsequence of the Fibonacci sequence as follows. A and B is equal to 0 and 1, right? Because A is 0, B is 1. Right. So if I say while A is less than 10, print A. Oh, yeah. Let's try this again. We know what A and B are. So we say while A is less than 10, colon, 1, 2, 3, 4. Print A. And then we say 1, 2, 3, 4. A, B is equal to B. A plus B. So what did it do? 0, 1, 1, 2, 3, 5, 8. By the way, A comma B oh, I see. Because all it's doing is repeatedly printing A 10 times. Because A starts off at 0. Actually, no, I'm wrong. It's a Fibonacci sequence. So A is 1, and then it's 1, and then it's 2, and then it's 3, and then it's 5, and then it's 8. The first line contains a multiple assignment. The variables A and B simultaneously get the new values 0 and 1, of course. On this last line. This is expressions first. Before the evaluations as the assignments take place, the right-hand side expressions are evaluated from left to right. Kind of like C. The while loop executes as long as the condition A is less than 10 remains true, of course. In Python, like in C, any non-integer 0 value is true, 0 is false. The condition may be a list or a string or a list value. In fact, any sequence along with okay. The body of the loop is indented. Indentation is Python's way of grouping statements. At the interactive prompt, you have to type a tab or a space for each indented line. In practice, you will prepare more complicated input for Python with a text editor. All decent text editors will have an auto indent facility. When a compound statement is entered interactively, it must be followed by a blank line to indicate completion, since the parser cannot guess what you have. Type for the last line. Note that each line with a basic block must be indented by the same amount. The print function writes the value of the arguments it is given. Right. The keyword argument n can be used to avoid the new line after the output or end the output with a different string. Right. So if I say I is equal to 256 times 256, and I can say print. The value of I is, and then we say I. Yep. The keyword argument end can be used to avoid the new line after the output, or end the output with a different string. End? 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 Huh? Huh? Oh, end the output with a different string because you don't want there to be a new line character. So unlike other languages, special characters such as new line have the same meaning with both single and double quotes. The only difference between the two is that the single quotes. How often are you going to see this though? Oh. Because watch this. Because I could say A comma B is 0 and 1. So here's A, here's B, right? So I say while A is less than 1,000, print A comma end is equal to, let's end it with banana because we can. A comma B is equal to B, A plus B. What? So it actually put a banana in between every number. Is that what happened? Ah. Right. Moving on. This is called More Flow Control Tools. How many topics are there? There's gotta be many, right? Right, because you got data structures. Is there a table of contents? Modules. Whoops. Wait, was modules the last one? In IO. Errors and exceptions. Classes. Of course. Gotta have classes, because why not? They have a tour of the standard library. There's a part 2. Virtual environments and packages, and we briefly touched on that. What now? Right. So where was I? Virtual environments, classes, and sections, modules, structures. So I think this is where we were. Yeah. How long have I been streaming? About 2.5 hours. Yeah, okay. I think that'll do for today. I might sign off and then switch to a different stream topic. So I think next time I do a programming stream, I'll just pick up from where we left off and we'll do more of the flow controls. We'll take it from there. But that's all for today. See you guys.